Mars has been killing its own atmosphere for 4 billion years. By the time we get there, it'll have about 0.6% of the air pressure you're breathing right now. This is why that matters. From orbit, you can see it. A thin rust-colored haze hugging the surface. What's left of an atmosphere that was once thick enough to hold liquid water? The reason it's gone comes down to one thing Mars lost billions of years ago, its magnetic field. Earth's magnetic field is generated by liquid iron churning in its core. Mars had the same thing and then it stopped. Around 4 billion years ago, the Martian core cooled and solidified, the dynamo died. Without it, Mars had no shield. The solar wind is a constant stream of charged particles fired out from the sun. Earth's magnetosphere deflects them. They curve around us and keep going. Mars gets hit directly. Those particles slam into the upper atmosphere and knock gas molecules into escape velocity. NASA's MAVEN mission measured this directly. Mars is losing around 100 grams of atmosphere per second to solar wind stripping alone. During a solar storm, that rate jumps 10 to 20 times higher over geological time. That's how you strip a planet. The result, Mars's atmospheric pressure sits at roughly 6 millibars. Earth's sea level is 1013 millibars. The Martian surface is equivalent to being 35 kilometers up in Earth's atmosphere. No human survives there unprotected, and no amount of warm clothing fixes that. The obvious question is, can we just rebuild the atmosphere? Mars has CO2 locked in its polar caps and soil. In 2018, Joukowsky and Edwards mapped every accessible source on the planet. If we released all of it, every last bit, we'd reach maybe 15 to 20 millibars. Not breathable, not even close to enough pressure for liquid water to survive on the surface. The CO2 simply isn't there to do the job. For a colony, the missing magnetosphere isn't just an engineering problem, it's a daily medical one. Galactic cosmic rays penetrate the surface continuously. Solar particle events hit without warning. Long-term exposure raises cancer risk, causes cumulative neurological damage, and makes reproduction on the surface genuinely dangerous. Every hour outside a shielded habitat is a dose of radiation your body doesn't recover from. So the first design constraint for any Mars colony is shielding, and it shapes everything. Thin aluminium, like early space station modules, actually makes things worse. High-energy cosmic rays hit aluminium and produce secondary radiation showers. The right materials are polyethylene, water walls, or regolith. Mass is what stops these particles. The most practical solution already exists on Mars. Lava tubes. When Mars was volcanically active, flowing lava formed underground tunnels. Lower Martian gravity means those tunnels are enormous, up to 250 meters across, based on orbital data. We've found evidence of them via skylight pit craters seen from orbit. Dark holes where the ceiling has collapsed. They haven't been directly explored yet, but the indirect evidence is strong and they're a serious target for early missions. A colony built inside a sealed, pressurized lava tube gets meters of rock overhead, effectively free radiation shielding. It also solves micrometeorite impacts and provides thermal stability. It's the habitat design most actively studied by researchers for early Mars settlement. For any surface structures, the approach is to bury them. 2 to 3 meters of Martian regolith piled on top reduces cosmic ray dose to levels comparable to low Earth orbit. The challenge is moving that much material. It requires significant robotic infrastructure deployed before humans arrive. The long-term proposal is more ambitious. In 2017, NASA scientist Jim Green proposed a magnetic shield at the Mars L1 Lagrange point. The gravitational balance point between Mars and the Sun, a large enough electromagnetic structure there could deflect the solar wind before it reaches Mars, allowing the atmosphere to slowly rebuild over centuries. It's a real scientific proposal, not science fiction, but the engineering scale is beyond anything we've built. The missing magnetosphere is the foundational problem of Mars colonization. Everything else, the habitat design, the medical protocols, the power budgets, follows from it. Next episode, what a colony actually looks like day to day and how you keep people alive inside it.